Hey, it's Mr. Luneski, and we today are looking at arc length and area of sectors for circles. Area of sectors can help us answer questions like, what's the area of this piece of pizza? So math just got important, y'all. Alright, in class we actually went through and did the odd problems together. So I'm actually just going to go through and do the even problems with you in case you need those for extra help. But I'm still going to kind of go through and re-explain some of the stuff to you in case you were absent. So circumference of a circle essentially is if you took a piece of string and laid it around the circle and then measured the piece of string. It's sort of like a perimeter of a circle. The formula for that is circumference equals 2 pi r, or you could say circumference equals pi times the diameter, because as a reminder, the diameter is equaled to 2 radii. So remember, a radius is kind of half the circle, diameter goes across the whole circle. We'll do this problem together here. Number 2, it says, given that the circumference of a circle is 2 pi meters, find the radius. So we're basically just using our formula, circumference equals 2 pi r. And we're substituting in for what we know. We know given the circumference, so we're going to substitute 26 pi in for c. So 26 pi equals 2 pi r. And then we want to solve for the radius. So we're just solving for the radius here. So I can divide both sides by 2 pi. Pi is just some number that we can kind of divide by as well. We don't have to do it in pieces. We can divide 2 pi as sort of a whole thing. The cool thing about the pi's is that those are going to cancel out. 2's here cancel out, and now we're just left with 26 divided by 2, which tells us that the radius is 13. The arc length of a circle, it's the same thing as circumference, except you're doing a fractional piece of the circle. You're not looking for what's this whole circle, you're maybe just looking for what's the length of this little piece, that if you took a string on just that arc, what would that be? So really, it's still just the circumference formula. We still have 2 pi r, but then you just multiply it by whatever fractional piece of the circle you're interested in. That fractional piece is always going to be essentially your angle divided by 360. And that typically we're given central angles here. So it's the central angle divided by 360. So again, we'll do number 4 together. So we're finding the arc length of AB. So we're trying to figure out how long is this piece here. And so we're going to use our formula, 2 pi r times the angle over 360. We're told that the radius here is 11 meters, so we'll do 2 pi times 11 times the central angle here is 120 over 360. So again, however you are comfortable in terms of simplifying this, you can do 2 times 11 is 22 pi times, and then 120 over 360 as a fraction simplifies to 1/3. So in exact form, this is what my answer would look like, 22 pi over 3. But as a decimal, again, you can just kind of pop all of this right here into your calculator. That comes out to be about 23.03 meters. Don't forget your unit there. So yeah, that would be the length of this arc here. Area of a circle. The area of a circle formula is area equals pi r squared. We just use that to find sort of the covering of a circle, how much area covers the inside of a circle. So we'll do number 6. It says find the area of the circle if its radius is 25 meters. So really, again, we're just using area equals pi r squared. We are finding the area. We are told the radius is 25 squared. So just remember that you're squaring the number here, not the pi. So when we square that out in exact form, we get 625 pi. Or if we multiply that pi as 3.14, get this as an answer. Just remember though that your units are always squared. So here we had centimeters squared. Area has units squared. Looking at the last problem here, area of a sector. So again, we're just looking at still the area of a circle, but now the sector is sort of a fractional piece. So my formula is still the same thing, pi r squared, area. But now we're saying not the whole circle, but a fractional piece of the circle. So that fractional piece will be the angle over 360, central angle. So this one's a little bit different. It says find the area of the shaded region. So we're finding this area. So we actually aren't given that angle. We're given this angle. But we know there's 360 degrees in a circle. So if this is 120, that makes this 240 degrees of the shaded area. So again, we're going to use our little formula here, pi r squared times the angle over 360. The radius is 14. The angle that we are in the shaded area with is 240. And now we just simplify. If you want, you can type this whole thing into your calculator and just get your decimal answer. If you want to put it in exact form, that's good too. In exact form, it's 392 pi over 3. Or as a decimal, you would get 410.3, roughly, feet squared. Alright, that is it for our circle arc length and areas of sectors. Thanks for watching.